Welcome to the Deep Dive, where we cut through the noise to get you truly well-informed. Many of us feel it, right? A growing unease, maybe a crisis of trust in our centralized institutions.
Yeah, definitely.
Whether it's, the integrity of elections, the transparency of monetary policy, or just that feeling that decisions are made behind closed doors, we're sort of constantly searching for a better way to organize society.
That's a powerful observation. And it's not just a fleeting sentiment, is it? It feels like a real global search for alternative models. How can we organize ourselves differently? And that search has really converged with the maturing of blockchain technology.
And that's exactly why today we're taking a deep dive into one of the most ambitious and, well, sometimes chaotic attempts to build an entirely new form of digital social contract. The EOS blockchain ecosystem.
Right.
This isn't just another cryptocurrency story, It's really a comprehensive toolkit designed to rethink everything from governance to economic policy.
Yeah, our mission for this deep dive is to unpack how EOS was engineered to revolutionize the very functions of a state. But maybe even more importantly, why its turbulent history offers such a profound cautionary tale.
A cautionary tale, how so?
What really shows us that the biggest hurdles to true decentralization aren't technical, not really. They're deeply human. Things like coordination, political economy, and the immense challenge of administering power justly.
Okay. So this deep dive should give you a shortcut, then, to understanding a groundbreaking effort to decentralize power, with some surprising insights into what works and, crucially, what doesn't when you try to govern by code. Okay, let's unpack this.
You do.
So, to understand EOS's incredible potential, maybe its original potential, we first need to look at its core architectural components. These aren't just like technical features. They seem like deliberate design choices, creating a unique political and economic framework for, well, what you could call a digital state.
Exactly. And at the heart of it all is something called Delegated Proof of Stake, or DPoS.
DPoS.
That's right. DPoS, which was created by Daniel Larimer, is fundamentally a representative democracy, but it's designed for incredibly high performance and scalability.
So different from Bitcoin's proof of work.
Very different. Unlike proof of work or even many traditional proof of stake blockchains, DPoS doesn't involve everyone participating directly in validating transactions.
Okay, so how does it work then?
Instead, EOS token holders vote for 21 block producers, BPs they're usually called.
21, that seems like a small number.
It is, and that's key to the design. These 21 BPs are the ones validating transactions and creating new blocks on the blockchain. Your vote weight is proportional to the number of tokens you've staked.
So more tokens, more voting power.
Correct. But importantly, any user can participate in the voting.
And these 21 BPs, they're working fast.
Incredibly fast. They produce a new block every 0.5 seconds. The aim was always millions of transactions per second, speed for industrial scale applications.
Wow, half a second.
And what's fascinating here is that BPs are held accountable through continuous elections. They can be voted out if they perform poorly or, act maliciously. They even risk losing their staked tokens.
It's essentially a political system on steroids, isn't it? Almost like an elected oligarchy running the show.
You could see it that way.
That kind of concentrated power, even if it's elected, seems ripe for the kind of political dynamics we see in the real world.
That's a very apt observation. These 21 active BPs function as the network's executive branch, basically, running the infrastructure, validating transactions.
And didn't the original design even have something like a legislative branch, too?
It did, yeah. Originally, there was a separate group of delegates that were voted in to propose changes to system parameters like block size, fees, BP pay, almost like a legislative body. Users would then vote on those proposals.
So token holders are the electorate, BPs are the executive, delegates were the legislature.
Exactly. The token holders are the sovereign electorate, granting legitimacy through that continuous voting. It's incredibly efficient, this model.
But efficient comes at a cost, right?
It does, as you hinted at. This very structure, while scalable, makes a deliberate trade-off. It sacrifices broad participation for that speed and throughput. It concentrates operational power in the hands of just a few.
And that tension between efficiency and decentralization.
It's absolutely central to DPoS's critiques.
Yeah.
It's a key part of that cautionary tale we mentioned.
Right. If you compare DPoS to something like, say, direct democracy.
The difference is stark. Direct democracy has low scalability, slow decision-making, because it requires mass participation.
Whereas DPoS boasts, very high scalability and extremely fast decision-making precisely because it concentrates responsibility.
That's the trade-off in a nutshell.
Okay, now let's talk about how EOS handles its network resources. This seems like another radical departure from what we see on most other blockchains.
It really is.
Instead of paying a gas fee for every single transaction like on Ethereum.
Which can get expensive, especially for users of popular apps.
Right. EOS uses a resource-based model. Owning EOS tokens grants you proportional access to the network's public infrastructure. The goal here was to enable free end-user experiences for large-scale applications.
Yeah, that was the vision. And it's truly built on three essential resources. You've got CPU, which is processing time measured in microseconds.
Okay.
Then net, which is network bandwidth, measured in bytes.
Got it.
And finally, RAM, which is persistent state storage, also in bytes. And crucially, RAM is finite.
Finite. So like digital land almost.
Kind of like that, yeah. Think of RAM as the digital hard drive of the EOS blockchain. It's where permanent data, like account information or application states, is stored. Scarcity is built in.
And the way these resources are managed, it hasn't stayed the same, has it? It's evolved.
Oh, absolutely. It's been a live on-chain experiment in the economic policy.
Really? Like what?
Well, initially, users would stake their EOS to reserve a proportional share of CPU and net.
Seems logical.
It did, but it proved incredibly inefficient. Many users had idle resources just sitting there, which paradoxically caused scarcity for active applications that actually needed them.
Ah, the tragedy of the commons.
Exactly. Playing out in a digital space, it was a profound insight. Even on a super advanced blockchain, basic human economic behaviors and resource management challenges are just inescapable.
So how did they fix that?
Well, they tried. To address that, the Resource Exchange, or REX, was implemented. This created a decentralized leasing market.
Leasing.
Yeah, token holders could lend their unused CPU and net for rental fees. Those fees were paid from sources like RAM trading fees and account name auctions. It was a big step towards a more market-driven allocation.
And now there's something called Power Up.
Right, that's the current system. Under Power Up, users pay a small EOS fee to essentially power up their account for 24 hours. This grants them a significant amount of CPU and net.
So you pay a small fee for temporary access rather than tying up lots of capital staking?
Precisely. And those fees are then distributed to all EOS token holders who have staked their tokens in a central pool. It makes it a much more predictable and, frankly, cost-effective public utility model for developers and users.
Okay. And RAM, you said it's finite and managed differently.
Indeed. Since RAM is finite, unlike CPU and net, which regenerate, it's bought and sold directly through a system smart contract. It uses something called a Bancor algorithm.
Bancor algorithm. Sounds complex.
Think of it like a constantly adjusting vending machine. The price automatically goes up as demand increases and the supply dwindles, and vice versa. It ensures fair pricing and continuous availability without needing a traditional order book market.
And that makes RAM itself tradable.
Exactly. It becomes a tradable and often speculative digital commodity within EOS. There's even a 0.5% transaction fee on RAM trades that helps fund the system.
Okay, fascinating economic model. Finally, for this section, let's explore how EOS approaches the concept of law and agreement. Smart contracts, obviously, but also something called Ricardian contracts.
Yes. EOSIO, the underlying software, supports industrial-scale applications. The contracts are written in a powerful language like C++A, then compiled to WebAssembly or WASM.
WASM, right. That makes them fast.
Near-native execution speeds. Critical for supporting large-scale apps. But here's the really crucial part, and it's controversial. These contracts are upgradable.
Upgradable, so not immutable like Bitcoin code.
Correct. That upgradability is definitely a double-edged sword. It allows developers to fix bugs or add features without a disruptive hard fork, which offers incredible flexibility. But it also concentrates power. Who gets to upgrade the contract? Though this power can be managed, often via multi-signature controls, meaning multiple designated parties need to approve any change.
Okay. And then there's a Ricardian contract. What's that about? Sounds old-fashioned.
It's actually a concept developed by Ian Grigg back in the 90s, well before blockchain really took off. It's a very clever innovation. It's essentially a legal document you can read and understand, just like a regular paper contract.
Okay, human readable.
But it's also formatted in a way that the blockchain itself can read and execute automatically. Machine parsable.
Ah, so it bridges the gap between legalese and code.
Precisely. It bridges that gap between traditional legal agreements and the cold, hard code of smart contracts. The idea is to ensure the intent of the agreement is crystal clear to both humans and machines, avoiding that whole code is law ambiguity.
So every action requires agreeing to the terms.
On EOS, ideally, yes.
Yeah.
Every on-chain action is intended to be tied to a Ricardian contract, explicitly stating the terms before you cryptographically sign and approve the transaction.
And this all culminated in the original EOS constitution.
It did. Here's where it gets really interesting. The Constitution was a governing document users actually had to accept, and its hash, like a digital fingerprint, was included in every single transaction.
Yeah.
It was a truly groundbreaking attempt to codify a legally binding social contract for a global digital community.
Sounds incredibly ambitious.
It was. But as we'll get into later, this ambitious framework almost immediately faced profound difficulties in interpretation and enforcement, particularly with its judicial body. That became a significant part of EOS's cautionary tale.
Right. So these architectural components, DPoS, the resource model, these contracts, they provide a really robust toolkit for building alternative models of governance, aiming to be more transparent, efficient, participatory.
That's the goal, yes.
Let's look at how legislative and executive functions could, theoretically, operate via this on-chain governance.
Okay. So we can envision a kind of bicameral digital legislature. You've got the assembly of token holders, maybe like the lower house.
Well, the EOS holders.
Right, acting as a direct liquid democracy, expressing the popular will through that continuous voting mechanism.
And then the upper house.
That would be the Council of Block Producers. Those 21 elected BPs acting as an executive council. Protocol upgrades, system contract changes to these major decisions are executed via a multi-signature transaction.
Multi-sig, meaning not just one BP can make a change.
Exactly. It typically requires a supermajority, like 15 out of the 21 BPs, to approve. That creates a significant check on power, at least in theory.
So new laws are basically new code.
In this model, yes. New policies are transparently coded into new system smart contracts, if the BPs approve it with that multi-sig.
The 15 out of 21.
Right. Then the new code is deployed on-chain, automatically updating the network rules for everyone. It effectively transforms lawmaking into an auditable software update.
And other chains are using this model now, too.
Yeah, the Antelope Coalition, which includes EOS, Telos, WX, and UX Network, has really taken this concept of on-chain lawmaking and extended it. They're collaborating almost like a federation of allied digital states to jointly govern and update the underlying Antelope technology. It creates a more unified and powerful ecosystem across their blockchains.
Interesting. But purely on-chain mechanisms weren't enough, were they? There was criticism about Block.1, the original developer.
That's a critical lesson from EOS history, yeah. Block.1 raised billions in its ICO, but faced heavy criticism for, well, not reinvesting enough of that back into the ecosystem's development as many expected.
Which led to
the emergence of the EOS Network Foundation, or ENF, in 2021. The community essentially decided to fund its own development.
How is it funded?
Through increased network inflation, a decision made by the BPs via that governance process.
Yeah.
The ENF has essentially become the network's primary coordinating body. Think of it like a well-funded executive agency or maybe a civil service.
Doing what exactly?
It handles core protocol development, coordinates public good funding, manages ecosystem communications and marketing, basically filling the void Block.1 left.
And its success.
The ENF's relative success highlights something really important. Even supposedly decentralized systems often need focused, human-led organizations to fill strategic gaps that code alone just cannot address. It's a surprising insight into the limits of pure code.
Okay. Now, EOCO, the software, was also designed as an operating system for DAOs, right? Decentralized Autonomous Organizations.
Explicitly, yes. It's high performance, the potentially feeless user experience, human-readable account names, sophisticated permissioning. It's all ideal for building and managing complex on-chain organizations that could even provide public services.
Public services run by DAOs, like what? Give me some examples.
Okay, well, imagine public records management. Property deeds, birth certificates, business licenses, all issued as NFTs on the blockchain.
Non-fungible tokens, unique digital assets.
Right. Immutability prevents alteration. Smart contracts could automate processes like transfers. And maybe a DAO of citizens governs the whole system, offers unprecedented transparency compared to dusty old filing cabinets.
That makes sense. What else?
E-voting systems. EOS potentially provides infrastructure for secure, transparent electronic voting. Each verified citizen could get a unique identity, maybe linked to a non-transferable voting token.
So no selling votes.
Hopefully not. Votes become immutable blockchain transactions. It could eliminate whole categories of electoral fraud and, crucially, remove the need for trust in opaque, centralized vote counting systems.
Big potential there.
And decentralized identity or self-sovereign identity. The EOS account system, provides a foundation for this. Your digital identity is controlled by you via your private keys. You could grant granular, revocable access to specific pieces of data, like proving your age without revealing your birth date. Enhances privacy while streamlining authentication.
Okay, those are compelling possibilities. Now let's circle back to the EOS Constitution itself. You called it a fascinating yet cautionary case study.
It really was a truly groundbreaking attempt to establish a legally binding social contract enforced by code and human arbitration.
The arbitration part, that was ECCAF.
Yes, the EOS Core Arbitration Forum, ECKF, that was envisioned as the on-chain judicial body, interpreting the Constitution, resolving disputes between users.
Yeah, sounds necessary. How did it go?
Well, it was almost immediately beset by controversy.
Yeah.
It turned out to be slow, very opaque,
Huh?
which is kind of the opposite of what you expect from a blockchain.
Slow and opaque justice. Not ideal.
Not at all. It felt like they tried to build the Supreme Court of the internet and instead ended up with, well, something a bit more like a poorly run online forum handling major disputes.
Yeah, that doesn't sound great. You mentioned a crisis.
A major one, early on. Block producers, in what was controversially dubbed a consensus by conference call, literally a phone call between the top BPs.
Not exactly on-chain governance.
Not at all. They unilaterally decided to freeze accounts suspected of phishing. Now, stopping theft is good, but they did it without an ECIF order, which directly violated the Constitution they were supposed to uphold.
Ouch! So the executive branch overrode the rules.
That's exactly how critics saw it. Extra-constitutional action by an elite group. A clear crack in that whole code is law facade.
And it got worse.
It devolved from there, yeah. ECF started issuing orders, but they were often confusing, lacked clear rationale. Some are just PDFs posted somewhere. And some BPs simply refused to enforce them. There was no clear enforcement mechanism.
Jurisdictional chaos.
Complete chaos. The judicial branch effectively collapsed when one arbitrator issued an order that really crossed the line.
What was that?
They ordered the reversal of transactions that had already been confirmed and finalized on the blockchain.
Reversing immutable transactions. Isn't that against the whole point of blockchain?
Absolutely. It sacrificed the core blockchain principle of immutability for a subjective notion of justice. It sent shockwaves through the EOS community and the wider crypto space.
Wow. So this really raises a huge question, doesn't it? What are the limits of trying to do justice purely on-chain?
Exactly. The ECFF failure dramatically demonstrated the immense difficulty, maybe the impossibility, of bridging nuanced human legal systems with all their interpretation and context with rigid, immutable code.
So the Constitution and ECF were eventually replaced.
They were. The whole experiment led to ECF being scrapped and replaced with a far more minimalist EOS user agreement, the EUA.
What did the EUA do differently?
It largely abandoned the idea of on-chain human arbitration for subjective disputes. Instead, it gave the BPs explicit emergency authority, the power to freeze accounts or take other actions if they could get that 15 out of 21 supermajority vote.
So a retreat from the grand vision back towards more centralized control by the BPs in emergencies.
Essentially, yes.
Mm.
It was a pragmatic, perhaps necessary retreat from an overly ambitious vision that just didn't work in practice.
Okay, shifting gears a bit. The EOS ecosystem doesn't just provide tools for governance. It offers a framework for completely reimagining monetary and fiscal policy too, right? Moving central banking and public finance onto a transparent, decentralized ledger.
Exactly. Take programmable monetary policy. The original EOS model had a perpetual 5% annual inflation.
5% forever? How was that used?
Well, 1% went to block producer rewards, basically paying them for running the network infrastructure.
Okay, compensation.
And the other 4% was allocated to something called the Worker Proposal System, or WPS. The idea was to fund public goods and ecosystem development projects voted on by the community.
So using inflation like a government uses seniors, the power to print money to fund public spending.
Precisely. That was the analogy.
But that model didn't last, did it? The community changed its mind.
It did. The perspective shifted significantly. Firstly, that worker proposal system proved largely ineffective, as we'll discuss. And secondly, there was a growing market preference, across crypto for scarce deflationary assets, more like Bitcoin.
So what happened?
In May 2024, the community reached consensus through that BP multi-sig process to fundamentally alter the tokenomics.
This feels like a monumental shift. What's the real significance here? What does this tell us about decentralized monetary control that maybe we haven't seen before?
This is precisely where the aha moment truly lies, I think. This wasn't just a minor tweak. It was a fundamental macroeconomic regime change for the entire network. And it was enacted entirely through on-chain governance by the token holders' elected representatives.
Wow. So what did they change specifically?
The new policy eliminated that perpetual 5% inflation entirely. Instead, it established a fixed maximum supply of 2.1 billion EOS tokens.
Like Bitcoin's fixed supply.
Exactly. And they implemented a 4-year halving cycle for staking rewards, again, very similar to Bitcoin's model. It was a massive shift from an inflationary, utility-focused model towards a deflationary sound money model.
And all done via code updates approved by BPs.
Yes. It powerfully demonstrates that a digital community can, potentially, rewrite its own financial destiny through decentralized consensus mechanisms, a radical new form of monetary control.
Okay, now let's talk about that automated fiscal policy aspect, the public goods funding. You mentioned the worker proposal system, the WPS.
Right. The original vision for that 4% inflation stream was this WPS, a fully decentralized treasury.
How would it have worked?
Token holders would vote directly on project proposals submitted by the community. If a proposal got enough votes, payments would be dispersed automatically from that 4% inflation pool. It was envisioned as a pure form of participatory budgeting on-chain.
Sounds great in theory. Pure democracy funding development.
In theory, yes. But the WPS was actually never fully implemented as originally designed. And the community really struggled to reach consensus on how to distribute the funds effectively.
What happened to the money then? That 4% was still accumulating.
It was. Hundreds of millions of dollars worth of EOS piled up in the WPS account, unspent. It became a contentious issue. Eventually, the BPs voted to simply burn the accumulated funds.
Burn hundreds of millions. Why?
Partly because it was seen as an overhang on the market, partly because they couldn't agree on how to spend it productively. It really highlighted a key challenge. While direct democracy for spending sounds appealing, reaching consensus on how to allocate large sums of public money is incredibly hard, even for a highly motivated digital community.
So the decentralized treasury failed. How are public goods funded now?
We saw a shift from the WPS idea towards ENF grants. Public goods funding is now primarily handled by the EOS Network Foundation, the ENF we discussed earlier.
Ah, the coordinating body.
Right. It now receives 2% out of a new lower 3% overall network inflation rate. This more centralized, or perhaps focused model, where the ENFs make strategic funding decisions, has proven far more effective at actually deploying capital to support ecosystem growth.
So what's the lesson there?
If we connect this to the bigger picture, it suggests that effective fiscal policy, even in a decentralized world, often requires focused expertise, strategic planning, and discretion. Not just direct mass voting on everything. Sometimes a more centralized but still accountable body is necessary to actually get things done.
Makes sense. Okay, beyond governance and monetary policy, EOS's high performance also made it fertile ground for DeFi, right? Decentralized finance, building a parallel financial system.
Absolutely. Its speed was a major advantage early on. You saw decentralized exchanges, DEXs like Nudex, emerge quite early.
What was special about Nudex?
It offered a high-frequency trading experience that felt almost like using a centralized exchange, but it was non-custodial. You always retained control of your assets that weren't held by the exchange. That was only possible because of EOS's speed and lack of per-transaction fees at the time.
And more complex DeFi.
Yeah, projects like Equilibrium built full DeFi suites. They launched EOSDT, which was actually the first decentralized stablecoin on EOS. It was over-collateralized, backed by more value in EOS, and even wrapped Bitcoin than it represented.
So you could trust its peg.
That was the idea.
Yeah.
And Equilibrium supported lending, borrowing, margin trading, a whole range of financial services built on EOS.
And you mentioned earlier the unique resource model led to new markets, too.
Yes. The Chintai platform was a great example. It created a peer-to-peer leasing market specifically for those CPU and net resources we talked about.
So I could lend out my unused bandwidth.
Exactly. Passive EOS holders could stake their tokens and then lend out the corresponding CPNet resources to dApp developers who needed them, earning a yield in return. A completely novel financial market born directly out of EOS's specific architecture.
Okay, so clearly EOS had, and perhaps still has, a very ambitious and innovative design across governance, economics, and finance. But it's also faced intense criticism. Its history seems full of controversy.
That's putting it mildly. The theoretical elegance often clashed hard with the messy realities of human behavior and politics.
Let's get into that critical analysis. What are the main points of contention?
Well, the biggest, most damaging critique, the one that has dogged DPoS from the start, is that while it's scalable, it's inherently prone to centralization, or at least captured by cartels.
How so? What's the mechanism?
It's a combination of factors. You have stake-weighted voting, meaning large token holders have disproportionate influence. You've only a few very highly paid validator slots, those 21 BPs. And historically, you've had low voter participation from smaller holders.
So the big players dominate.
That's the concern. It creates strong incentives for potential BPs to collude, to form political cartels, to vote for each other and secure those lucrative paid positions, potentially ignoring the interests of the broader community.
And have we seen actual evidence of this? Or is it just theoretical?
There have been significant allegations and some compelling, though sometimes disputed evidence. The most famous incident was in late 2018. A leaked spreadsheet, allegedly from the crypto exchange Huobi, which was a top BP at the time.
An exchange being a block producer.
Yes, many large exchanges ran BPs, often voting with customer funds, which is another layer of centralization concerns. Anyway, this spreadsheet appeared to document mutual voting agreements and even kickbacks among predominantly Chinese-based BPs to lock in those paid positions.
Wow, like backroom deals.
Exactly. And on-chain data often seemed to support these claims. Analysts pointed to high vote confluence, meaning many of the top BPs were receiving votes from the exact same large accounts, suggesting coordination. Sometimes over 80% of the votes for different top BPs came from the same sources.
And the geographic concentration.
That compounded the issue. At various times, a significant majority of those top 21 BPs were controlled by entities based in China. This naturally raised concerns about potential censorship or influence from a single state actor. Larry Sanger, the co-founder of Wikipedia, who was briefly involved with EOS, very publicly warned about this concentration risk.
Okay, so potential cartels and centralization. What else?
Then there was the Whitelock Report in late 2018. This was a controversial independent investigation commissioned to analyze EOS's performance and decentralization.
What did it find?
Its conclusions were scathing. It claimed EOS was not a blockchain, but rather a distributed homogeneous database management system. It alleged that transactions weren't always cryptographically validated in the way people assumed, and that the actual transaction throughput was far lower than the millions claimed, maybe below 50 transactions per second in their tests.
50. That's a huge difference.
Huge. And they deemed EOS not truly decentralized. Now, the EOS community strongly rebutted many of the report's technical claims and methodologies, but the damage to EOS's reputation, especially early on, was significant.
So, concerns about centralization, performance claims, what about the voters themselves?
Voter apathy. That's been another persistent challenge feeding into the centralization problem. Voter turnout on EOS has been chronically low. A large percentage of the total EOS token supply has often never been used to vote at all.
Why is that a problem if people don't care?
Well, it creates a legitimacy crisis for the governance system. And practically, this apathy cedes enormous power to the few large token holders, the whales, and those centralized exchanges voting with customer funds who do vote. It makes it much easier for potential cartels to maintain control as they need fewer votes to stay in the top 21.
Have they tried to fix voter apathy?
There were attempts. Early on, there were concepts like vote decay, where your vote's weight would diminish over time unless you recast it regularly, maybe weekly. The idea was to force continuous engagement.
Did it work?
No, it failed. It was complex and unpopular. It just demonstrated that you can't easily solve fundamental issues of civic engagement with clever algorithms. Getting people to participate is hard, whether it's in a city council election or a blockchain vote. Some problems are truly universal, digital or not.
Okay. And the most dramatic failure, you said, was the attempt at on-chain justice with ECAF.
Absolutely. The collapse of ECAF revealed a fundamental paradox, I think. When you try to replicate nuanced human legal systems directly on-chain, you often end up relying on centralized off-chain processes, like arbitrators, making decisions in opaque ways, which completely undermines the legitimacy and the point of using a blockchain in the first place.
We talked about the consensus by conference call incident.
Right. BP is unilaterally freezing accounts violating the Constitution. Critics jumped on that as proof it wasn't truly decentralized governance, just ruled by an elite group coordinating off-chain.
And the jurisdictional chaos with EKF orders.
Yeah, unverified orders issued as PDFs, confusion, BPs refusing to enforce them. It was a mess.
But the transaction reversal was the breaking point.
That was the moment that really shook the foundations. An arbitrator ordering the reversal of transactions already confirmed on the blockchain. It sacrificed immutability, arguably the most fundamental promise of blockchain, for a subjective, contested notion of justice. It showed that even the rules of the code could be bent or broken by human intervention if the authorities decided to do so.
So the lesson there,
A purely on-chain system for complex dispute resolution, for replicating the nuances of law and justice, is likely unworkable. Real-world justice requires interpretation, discretion, context, things that are incredibly hard, maybe impossible, to capture purely in code without creating either chaos or centralized control points.
Okay, let's quickly recap that chronology of controversies just to see the timeline.
Sure. So soon after mainnet launch in June 2018, you had the BP consensus by conference call, freezing accounts, violating the Constitution.
Right.
Almost simultaneously, the ECA jurisdictional chaos began, leading to the effective collapse of the judicial system over the next few months.
Then later in 2018.
Late 2018, around October, November, the Huobi collusion allegations surfaced, providing apparent evidence of cartels. November 2018 also saw the damaging White Block report questioning decentralization and performance.
And the transaction reversal.
Also November 2018, that order sacrificing immutability. A very turbulent month.
And finally, the WPS failure.
The vote to burn the accumulated worker proposal system funds happened around May 2019, marking the failure of that experiment in purely decentralized fiscal policy. It's quite a list of challenges in the first year alone.
It really is. These are profound lessons. So, given all these challenges, a complete revolution of the nation-state using EOS, that seems unlikely now.
Highly unlikely, yes. That initial, very grand vision hasn't materialized. Instead, the pragmatic approach seems to be focused on incremental, targeted decentralization.
Using blockchain more like a tool to improve existing systems.
Exactly. Using blockchain as a foundational trust layer to augment rather than replace existing systems.
So what would that look like? What's a practical roadmap?
Well, you can think in phases. Phase 1 might be proof of concept implementations, maybe at the municipal or organizational level, where the stakes are lower and you can experiment.
Like what kind of things?
For example, transparent NGO and cooperative operations. A charity or a co-op could operate as a DAO. Members or donors vote on fund allocation. All transactions are on a public ledger for maximum accountability. Projects like EOS Daily tried this early on. It could really build trust in those sectors.
Okay, that makes sense.
Or local and community currencies. A municipality or a local business group could create their own local currency using a simple token contract, maybe EOSIO.token. Governed perhaps by a community DAO, allowing citizens some participation in local monetary policy.
And the e-voting and budgeting.
Yeah, a city could pilot an EOS-based e-voting system for, say, local council elections, or maybe for participatory budgeting, letting citizens vote directly on how to allocate a small portion of the municipal budget. Build civic engagement and trust from the ground up.
Okay, so start local. What's phase 2?
Phase 2 would be scaling proven concepts to specialized national systems, where blockchain strengths really shine.
Like supply chains.
Exactly. Supply chain and provenance tracking for critical goods. Think pharmaceuticals or high-value agricultural products. Using EOSIO's potential high throughput to create immutable records, tracking goods from origin to consumer. This helps reduce counterfeiting, ensures safety. We saw examples like Walmart China, using an EOSIO-based platform for food tracking, offers verifiable product authenticity.
What else at a national level?
Land and property registries. This is a huge issue in many parts of the world. Paper-based systems that are slow, inefficient, and prone to corruption.
So put titles on the blockchain.
Right. Property titles as NFTs, ownership records immutably stored, transfers via smart contracts. Could create transparent, fraud-resistant systems. And similarly, intellectual property management. Imagine national or global IT registries on EOS, each patent or copyright as an NFT, providing clear, time-stamped proof of ownership. Smart contracts could even automate licensing and royalty payments.
Okay, those are tangible applications. And phase 3, the ultimate vision.
Phase 3 moves toward a hybrid on-chain, off-chain state. This acknowledges the lessons learned. It leverages both blockchain strengths, automating deterministic processes, immutable records, transparency, and the strength of traditional human institutions for complex, subjective, ethical decision-making.
So not replacing government, but integrating blockchain into it.
Precisely. Blockchain serves as that trust layer. Government bodies could publish laws, regulations, budgets, public contracts onto the public ledger for radical transparency and accountability. Core administrative functions, maybe basic tax collection, dispersing social benefits could potentially be automated via verified smart contracts, reducing bureaucracy and error.
But humans still make the big decisions.
Yes, the human domain remains crucial. The legislative process of debating complex laws, the judicial process of interpreting them in specific contexts, the executive process of handling unforeseen crises, these would remain the purview of reformed, perhaps more transparent, but fundamentally human off-chain institutions.
It sounds more realistic, but still requires development, right? What are the key gaps that need addressing to make even this hybrid vision work?
Several key areas. First, scalable and private digital identity. A robust, self-sovereign digital identity solution is an absolute prerequisite for almost all advanced governance applications. You need to protect privacy while enabling reliable verification. That's a huge challenge.
What else?
Mitigating plutocracy in governance. We saw the issues with one token, one vote, leading to potential whale dominance and cartels. More research and implementation are needed for alternative voting mechanisms, things like quadratic voting, proof of personhood systems, reputation-based voting to make governance more representative.
And the justice system problem.
Critically, yes. Legitimate and scalable dispute resolution. Given EKCAF's failure, a new hybrid framework is essential. Maybe using blockchain to immutably record evidence and perhaps enforce final agreed-upon rulings, but relying on accredited, potentially off-chain arbitration services or even traditional legal systems for the complex adjudication itself. Finding that right balance is key.
So it seems every potential benefit comes with significant challenges.
Absolutely. If we look at those examples again, municipal e-voting offers increased trust, but the big challenge is ensuring secure, one-person, one-vote identity without violating privacy. Supply chain provenance gives you verifiable authenticity, but the challenge is onboarding all the participants across the entire chain.
Public records DAOs could give direct access, but raise huge data privacy concerns.
Right. Public goods funding offers direct influence, but can suffer from crippling voter apathy. Local currency systems might foster local activity, but need widespread adoption and legal recognition to be meaningful.
It's clear that each benefit comes with its own set of challenges that are often more social or political than purely technical.
It's never just about the code, is it?
It seems not. So, to recap our journey today, the EOS ecosystem provides, or at least provided, one of the most comprehensive and advanced frameworks we've seen for trying to decentralize governance and economic policy. It offered a really compelling, ambitious vision for shifting power.
It really did. But the core lesson from the EOS experiment is profound, I think. The most difficult problems of governance are not computational, but social. Technology, however sophisticated, isn't a silver bullet. It cannot, by itself, conjure civic engagement out of thin air or magically prevent political cartels from forming.
So the true potential, perhaps, of EOS and similar blockchain technologies lies more in that foundational role, serving as a trust layer for society.
That seems to be the emerging consensus, yes. An immutable, transparent, and potentially automated substrate upon which we can build more accountable and efficient institutions rather than trying to replace institutions entirely with code.
While the dream of a fully decentralized digital state might remain distant, the concepts pioneered by EOS, and maybe more importantly, the hard-won lessons from its struggles, they provide an invaluable blueprint, maybe a warning, for the future of governance in our increasingly digital world.
Definitely. It's a case study everyone involved in blockchain governance should understand.
So here's a final provocative thought for you to ponder. If that dream of a fully decentralized digital state does remain distant, what crucial human elements, things like trust, empathy, nuanced judgment, must always remain beyond the reach of code? And how can we best integrate those essential human qualities into our increasingly digital systems and societies?